Keep in mind, we are starting the root cause to every environmental problem. So obviously, this is an extremely important unit, understanding populations and the impact that every single portion of the making of a population has on the environment, okay? So we're going kind of backwards. Species within a population, these are like two terms that kind of were left out of the last unit. R and K, and I know you've heard of these before, right? No?
R and K.
R and K strategists, you totally heard about that in bio.
No.
Okay, so R strategists are these organisms right here. K strategists, as we go up this graph, are these, we're K strategists, okay? And there's a lot of differences which obviously impact population sizes. So what do you think they are? What do you think we vary from here to this shell over here, this oyster, I mean? Well, I mean that have to do with populations. Well, how? What do you think? What?
We don't make
There's more because, I wouldn't say there's more generally, but
They produce offspring at a faster rate.
there you go. They have a fast maturation stage. So in other words, they can have babies like lice. 1 week after they're born, they have reproductive. I'm going to keep bringing that up. Versus K have slow, and they have a lot of offspring. Like think about, dogs, right? Before. Because I would say now they're kind of different. They don't really have. Who has a dog?
Me.
Anybody have a dog that had babies? Did you see what just happened? I think we're causing evolution of dogs to have less litter. They used to have 7 and 8 dogs, and now it's like 1 maybe, right? It's dangerous for them too. A lot of babies is dangerous for any mammal. Let's say we have 1 baby at a time. Twins, triplets is already okay.
Barbara Streisand cloned her dog.
Yes.
That's weird, right?
Yeah.
Was it more common that people were having twins before?
Yes, it was more common. No,
It's more common now.
it's not more common at all. It's
Can't you make it so you have twins?
all right. So for like 3 slides or 4 slides, all we talk about is calculating populations. By definition, same species in a given area at a specific time. I don't know why I have that covered because that's review and you totally know this already. If we're going to count the number of people in this class, makes up the population what? I'm counting. We're 28 people and period C makes up the population blank of period C.
Number?
Yes, size.
Oh.
Now, look at the population of this class and see the distribution per unit area, right? What do we call that? Density. Obviously, well, not obviously. Which one do you think has a stronger impact on the environment? Density. When you're packed together, you're going to have a stronger impact on the environment. So if you look up today, the most populous country in the world, number 1 is China, number 2 is India. Who do you think number 3 is? But let's say China is like, I'm going to butcher this story, but let's say 3 billion people, and India is 3 billion people. I think it's 3.1 versus 3.2. So who do you think is suffering more?
India.
I mean, think of the size of India in comparison to the size of China, and they have almost the same amount of people. So is it really fair to say, let's calculate size? It's important to calculate in different ways, okay? Other ways is dispersion. What does that mean? Spreading, arrangements, yes. So we've got uniform, random, and clumped. Which do you think is the most popular? Clumped. Look at the class.
We're clumped.
We're always clumped.
Isn't that the social teacher?
It is. So why do you think organisms tend to be clumped?
For safety.
Safety is great. Reproduction is great. What else?
On Franco, is that why you're always pumping?
Whoa.
That came out in the video, people. So we obviously think of reproductive isolation. We need to be close together to be able to reproduce, care for our young, for safety. What else? Yeah, we're gonna look for resources. Like If you've seen the movie Planet Earth, the way they look for the water and they're always together. And teamwork, because we know that's necessary for survival, right? Whoops. How do we calculate population growth? What? Census will give us those numbers. What does the census look at? Good. We look at birth rates and we look at death rates. What else do we look at? If it's the census of the United States of America, immigration and emigration. Not a lot of emigration from the United States of America, but now if we're going to calculate growth, put all those factors into a formula. Birth plus
Oh, we did this.
birth plus IMI minus, this is a minus sign. Death plus ME equals growth rate. Good job. All right, so if population growth is birth plus ME minus death plus ME, what do you think natural growth covers?
Birth minus death.
Birth minus death. That's all. The picture should give it away for you, right? Now, these numbers at the bottom, I'm saying this in the video so you remember, are not, they're not figures you need to know on the test. I just put them there so you could be aware. From 2010 to 2012, our population in the United States grew 5.17 million. That's a lot. Contributing to that was 3.2 in natural increase, which means births and deaths, right? So there was a lot of immigration also as part of it. So in your slides, it had crude birth / death because it's the same formula, but I'm going to explain it to you. We calculate crude birth rates, which is the term that you used a minute ago, and crude death rates by taking the number of live births divided by the total population times 1,000 in a given year, okay? And they do the same for deaths. So if you kind of wanted to make a formula for it, I'll pause the video while I make it. So to take the vocabulary word and create a formula, number of births divided by total population, that total number times 1,000 gives you the crude birth rate. So how do you calculate the crude death rate?
Number of deaths over total population.
Thank you, times 1,000. So it's the same formula, okay? You just change the wording. Does that make sense? Yeah. And that is it for today, people.